It's always been great and good to speak to you all again. Hoping you all safe. Let's jump into the topic straight away. Today we're going to briefly discuss about classes, in particularly classes and objects. See, classes and objects or forms the basis of all the object-oriented languages, in particularly C++. It, it is the thing that sparks Jeremy Stroudstrup, who is the inventor of C++, who brings up the language called C++. And in the further slides, we will briefly discuss how C++ has been invented, or in terms of Jeremy Stroudstrup. Then we will going into classes and objects. Let's start with a contemporary beginning, and this is how my lecture, my teacher starts with C++ initially, years before, and you can see the code behind. C makes it easy to shoot yourself in the foot. C++ makes it harder, but when you do it, it blows your whole leg off. That's actually true. You know, to know what does it mean, you must know C++ from the inside. You must feel C and C++ from inside. Once you did it, you get into the C and C++, you will know what he actually means. He's actually the inventor of C++, Jeremy Stroudstrup, to whom we have been referring to the last slide actually. And he invented C++ in 1979 in AT&T Labs. Actually, like C++ is also not too many people are working from day to night to shape up C++. It is not the case actually. Jeremy Stroudstrup, and that particular time, he has been very busy in working a programming language called Simula, which is used to simulating the things. And with the idea he got from that language, he used to build on C actually, to bring up a new language with classes actually. So there are too many people who even call today C++ as C with classes. Even myself also, I do agree 50%. C C++ uh, is a language like C with classes. But it's not matter what you and me are describing C++. It does matter what Jeremy Stroudstrup describes it. Let's go and see what the creator defines C++. So here comes how Jeremy Stroudstrup has defined the language C++. C++ is a general purpose programming language with a bias towards system programming. That is the better C. It supports data abstraction, supports object-oriented programming, and supports generic programming. And we start off with better C. See, the symbol itself you came to know, which is very analogous to I++. We know what is I++. It is an incrementation. Similarly, C++ is an increment of C. C with classes. So in C++, the same, the solid is the base is same, the C, and we are building it with some additional features. That's simple as that. And we are keep on building with. Okay. And next we are going to data abstraction, and we have enough discussion on it in the initial of the class itself. And while with we concluded with an example here. Say for an example, we are using an integer I equal to 7 anywhere in a program, in a C program, which is easily accessible to any function that resides inside the function, inside the program. So anyone can access the value I, anyone can manipulate it, anyone can modify it, anyone can increment it, decrement it, whatever they want. They can do it with free. But that is not the case with C++, C++ brings in some additional security to the variables which have been used inside the program. So there is a very important feature or addition of the native C. And next comes the so much important one, object-oriented programming. And in fact, our subject is that object-oriented programming using C++. Our concern and focus is more towards that. And the entire course has been designed with a focus is on such part of it. Of course, we'll be discussing on other topics as well in the course. And what are the features of OOPS languages and how it can be implemented in C++, how a language C++ can be converted into object-oriented language, and why it is mandate, why it is necessary. And finally we came to generic programming. Programming is that we are writing a template, we are writing a model, and using the model we are creating several instances with several data types. And we'll be discussing more on particular topic when in the later part of the lecture. And yes, and here is the short history of C++. And in 1979, C with classes was first implemented, and the first manual has been published in 1982, and which is followed in 1984. The name was changed from C with classes to C++. So officially the language has been called C++ from 1984. Then the first commercial edition was released at the end of 1985 as C++ 2.0. And then we know there is a problem in C. Since it is an open source, anyone can write a compiler of it, anyone can create a compiler, which means your compiler can fix the memory value of integer as 2 bytes. I can fix my memory value as 8 bytes. No one can ask me. So there is a problem of this, because there exists too many compilers. So the portability of the language becomes a major issue, major threat. So then ISO stepped into it, and no, hereafter no one can change all such things. I'm going to release my own standard release. That release was released in 1997, in fact. Then the third edition got released at the end of 1997 as well, and which is followed by a number of additional features has been included as year by year. And now while we are speaking up, C++ the version 20 uh, has been published, which is most advanced version of C++, has been published already. So this is a short history of C++, and C++ is very special. This is the first of its kind. No other language can be can imagine objects. So this is the first language where it shifts its focuses from the functions, from the data perspective to the user perspective. The user perspective is the objects. In real time, day to day life, people always subjected to the persons, not with the data. So if you want to write a successful program to any real time problem, you must deal with so much of objects, so much of persons. So this is the first language that shifts the entire way of how we are seeing things over digitally. So to me personally, this is one of my favorite languages. So there is a saying that if you wanted to finish anything better, you have to start it much better, and I have a belief in that. So to understand the OOP concepts or any other OOPS languages, the basic understanding of class and objects is mandate, and it is very important, and it plays the important role in understanding all the other concepts. Is if you get into it perfectly, and all the other higher level of abstraction and concepts all are fall in place automatically. So we start off with a variable first. So what is a variable? A variable is something used to hold a data, a kind of a data. It is used to hold a value instead value. Okay. The next comes is function. So what is the purpose of a function? Why should we need to write a function? So before going into the function, we must know a statement. What is a statement? First of all, a statement is an action. Is just an action. So what could be the function then? So a function is a group of the statements that are going to do a similar task. Okay. For example, if I wanted to print a name on the screen, I cannot print it with a single line, single statement. It takes two or three statements. I have to read the name, then I have to store the name, then I have to display the name. At worst case, it takes three statements, and I have to group together these three statements and name, and I name it as a common name, for example display. And I call, if I want to display, I want to do perform these three things. So I put together these three statements and call it as a function. So that is the basic behind of writing a function. Instead of writing 100 lines straight away, doing the same task, we are writing the same 100 lines but with some clarity, and we are naming with the tasks, with reference to the tasks. So function is always dealing with what we are actually going to do with the values. So that is the thing. Then we are moving on to object and classes. So we first generally discuss about what is objects and classes in general English, and then go deeper into our aspects. So in general English, what is classes and objects? So we start off with objects actually. An object, what is an object? Object is a real world entity, that any entity that you can hold, that you can seize, that you can feel. So whatever we are seeing in the real world is an object. So how can we categorize, how can we say it is an object? So there is a and this is the place where no textbook explained it. So how can you say it is an object? So every object is different from each other. So this is what we should understand it. So if you wanted to call it as an object, this object must not be similar to some other thing. So every object has unique properties. So see, we are not speaking about the characters. We are speaking about the values. We are speaking about the attributes. For example, if the object is a person, if the object is it is you and me, we both are humans. Okay, we have similar properties. We have two eyes to see, two ears to hear, two legs to walk, and similar aspects. So in this case, are the two human beings are same? Are we thinking similarly? Are we doing things similarly? No. Though we are, though we both are humans, we are not the same. We are similar, but not same. So that is what you should understand from the objects. So objects are similar, but they are not same. Okay. Then how can you differentiate it with the students and a teacher? So both are humans. Okay. Are they doing the same things? No, they were not. In this case, these objects are of same to the class human with respect to the physical attires, but the way behaving with that is different. So for example, let's say a subject called oops. What is oops for you is a subject you are used to writing an exam, and you move on to the next semester. What is the same oops for me? It is a subject I'm going to teaching for a class, and I'm evaluating it and awarding grades and then moving to the next class. So with the same oops, we both are doing two different things, two different aspects. So this is subclasses. Okay, that we will dive into it in later states. So now you understand what is class without I'm even telling. So class is used to classify the things. So what is there inside a class? A class can have two different things. One is state and another is behavior. State is also called as attributes. That is how we have defined how a human being would be: two eyes, two ears. These are the states. And what is a behavior? So yes, we both are having mouth to speak. Does Are we speaking the same, or does it same? No, we are having hands to write. Does both of our handwriting are matching with each other? No. So this is how you to classify the things with respect to the way they behave with the attributes they had. And this is what I wanted to insist. And in the backslide there is a person, and there is two subclasses: patient and physician. So both were the patient, sorry, both were the human, both were the persons, but with respect to their attires, with respect to their unique properties, sorry, unique attribute values. One is considered as patient, another is considered as physician, as a doctor. So both are similar, but they are different. So this is the aspect between objects and classes. So in real world, all the things, all the objects have the unique attribute values. So C does not fit here. So that is why all the recent languages are object oriented in nature. So here is another example. You look at the picture now from the bottom up. So there are five different kinds of objects are there, and sorry, four in fact. And two is a car, and another is a bicycle, and a boat. So there were four different objects, and you started to categorizing it on your own. And how did you categorize it initially? So we categorize it into two classes. One is the boat, and another one is the other three objects, and two cars and a bicycle. How did I classify it? You have to think it. And how did I classify it into two classes? And because one is on roadways transport and another is on waterway, so I using that particular attribute, I classify it into two types. Okay, now I have to divide it into another two types. I had three objects now: two cars and the bicycle. So it is very easy. I can classify cars into a similar group and bicycle into another class. So, and this is the analogy between is that lies inside class and object. So there are four objects, and how you're classifying it? So we are classifying it with their attributes and how they behaving with that. So since all are used to transport only, either cars or bicycle or boats, all the things are used to transport from one place to another. So the utility is the same, but the way of achieving it is different. So that is what I am insisting in the last slide. So this is the difference among this is how to classify the things, and in our aspects we are used to build the objects by writing a general class. In the same example, you look at the car. And how did you know these two different cars as a car? How did you know it? How did you classify these two cars as a cars? By looking at the structure, by looking at they're having the two wheels, and they're having a headlamp, and they're having a bumpers. If they are having it, and I categorize it under cars. That is why there is a blueprint on above these two cars. So with the reference of the blueprint, I'm categorizing these two objects as a cars. and that blueprint is class, and we call them as class. And this is how you, in fact, our human brain works. Our human brain, how our brain classify the different types of cars as a car, because we are assuming that a car has can have four wheels, it can have an engine and two lights, a steering wheel, and a glass ventilator, air ventilator and all. And we have an image of a car inside. That image is class, and the actual objects are the objects here too. And this is what I just wanted to convey you people. And this is how a class has been logically designed. So it has its name, its own attributes, as well as the behaviors. So the attributes are our values, and behaviors are the functions that works upon the particular values. Which means, if I wanted to call a particular function, all the objects, all the inputs that needed to call the function should reside inside the class. You must not go outside. It is like a self-dependent country. Once you go inside, whatever you want, everything there must be inside. So this is how you should design a class. You must not go out. Okay, and how the messages can be passed among them. Similarly, see in C language, all the messages has been passed among the functions by calling the functions. Here, all the messages are passed among the classes. So there is another thing you might have noted here. The attributes and behaviors of one class is independent of the other class. There is no connection among them, and they are independent. And you can access any attribute or behavior of a class by creating an object to the particular class. And you cannot access uh, the behaviors or attributes, which means the functions and variables inside a class is cannot be accessed outside without creating an object to the class. So this is an important point, and which is and this process of putting together the functions and data is called encapsulation. And since we are providing an additional security, this is called data abstraction. And here is how the abstraction is achieved. The data abstraction is achieved in C++ by implementing classes and objects. And we had enough discussion about how the classes and objects um, have been logically designed, and what is all about classes are, and how they were classified, and how what is about uh, the attributes, and what are the attributes and behaviors, and how they have been interlinked among each other, and all such stuffs with reference to class. So all the explanations we had so far are from the class perspective, and this is one such explanation. From the object perspective, it is very interesting. In fact, uh, you see the picture behind, and this is the first slide. Sorry, in this slide, uh, there is a class called student, and if someone called a student must have, I'm explaining what are the things that student must possess. And if an object, if something has to be called a student, he should have all such things. So what are the states actually? Name, age, color, and sex. And behavior: eating, drinking, and running. So the states or the variables or the values, and behaviors or the functions or methods. So this is that we have known already. And look at the objects. So there are three objects. One is The name of the first of object is Peter, of age 3, and white color male. Again, the second object is John, of age 4, of brown male. And the last one is Julie, of age 2, of white color and female. So you see, so these four things or variables all are having name, age, color, and sex. Again, there are three behaviors, and one is Peter can eat more foods. There are, and with respect to eating, John can eat less foods. Julie can eat less foods. So here you see the way they behave among each other in eating. The task eating is they differ from each other, but they possessing it. But all the three objects were both Peter, John, and Julie. All the three were eating. So they are doing the task, but in a different perspective, but in a different level. So that is what we have to be noted here. And second is that they're drinking. Peter can drink more water, and everyone have drinking water only. Okay, can drink more water. John can drink more water. Julie can drink less amount of water. But again, here also, all the three objects were drinking, but the different amount of water. They're not the same. See, and of course, similarly running, where where Peter and Julie can run fast, John cannot run that much faster than Peter as well as Julie. So every single object has their own attributes. They have own identities. They are unique. They are not same to each other. So the theme of the thing is that even though all the objects are similar, even though all the objects possess the same name, age, color, and all the attributes, and even though all the objects are doing the same things, eating, drinking, and running, but they have different values. It is possible to have different values. So now you can understand why object oriented languages are very important, or talk of the town these days, because this is how we have been living in the real time world. No two members are similar to each other. See, in our class there are 59 students. Though they were students, they are not all the same. They are not all together the same. They are not behaving exactly same. They are not doing the exact same things. So that is what is all about. That is why object oriented languages are very much important, or had become in fact a mandate for every IT student, or everyone who wanted to work as an IT techie. It becomes a mandate now. So here there you can see objects are same as real world objects. Yeah, in the next slide we are going to do a little bit programming aspect. We are going to write a program with a class that has two different objects. In particular, in such particular program, we are going to do two different tasks: how to write a class, and how to define an object, and how to give values to the attributes residing inside a class using the objects. So these are the things we are going to see in the next recording, actually, in the program. See you there. See, already I have written a sample program to how to create a class in C++, and how to define object for the class. And here it comes no name.cpp. It is, yeah, okay. So I wrote a class called try. First I brief the program, entire program, and then we go to line by line. Okay, so I write a program by using a class to read two values and add two values and display it simply. Okay, so to accomplish this, I need two functions. One function is to get data, and another function to display the result. And to add two numbers, we already know that we need a, b, and c, two input variables a and b, and one output variable c. So these are the outcome, sorry, the outlay of the program we are going to write. So whenever you are about to write a program, you must know what are the functions you must write. You must already plan it, then only you can write. It is not like writing a song from the line number 1 to the last word. So you must analyze it, and you can create a blueprint of the program which you are going to write initially. Then you start writing the program, and this is the way how to approach any program. Whatever the program might be the addition of two numbers, as in the example now we are going to see, or it can be any real-time program. The proper analysis is must. Okay, let's go into it. And all the input and output of the C++ program is in streams. A stream is a physical abstraction of the device from which the input is fetched from, or into the device to which we are going to display the output. So here we are going to use both input and output streams. So since we are including IO stream and IO manip, that we will be discussing it later, and conio.h, actually this is the console input output. We are going to use getch somewhere in the main function, and this compiler is turbo C++ compiler. In some other compilers, I'm not sure about including conio.h, because I'm not you cannot ensure because some compilers will accept it, some compilers will raise an error. So in this turbo compiler it accepts it, so we are using it. And I start with writing a class. This is how you must write a class. Class is the keyword and a space which is followed by the class name. Here I use try is my class name, and the open bracket, and the first line is private. This is the access specifier. Who are all going to use the the following variables or functions? By default, all the variables are private in a class. If you wanted to call or access the variables or functions outside the class, you must put it under public. That is why I put all the functions under public, because I want to call the functions, so that only I can manipulate the data as a, b, and c. By default, if you put a, b, c also under public, there is no purpose of writing a class. You can write straight away into the main function itself. So the one of the primary concern of C++ is the security it provides to the variables. So it is a good practice that you must write all the variables under private, so that no other functions or any other values can access the variables a, b, and c outside the class try. So these values variables a, b, c cannot visible outside the class try. Okay, then we are proceeding to the public, and there are two functions, void get data and void display, and I'm not going to define inside the class. You can see it, there should not be any definition inside the class. Okay, then it is followed by the close parenthesis, and there comes the try one semicolon. This try one is the object. This is the first way of creating an object to a class. Okay, now up to this we have one class called try, and there is an object try one to the class try, and there are two more functions inside the class and three variables inside the class, and those three variables are private, which means it is not accessible to anywhere else. Okay, then we are going to main function. So as in C++ also, the execution always starts from the main function. So the main function starts here, and see the first line, try space try to, which means it is similarly like int a comma b comma c. I'm defining another object try to. So try to is the new object I am creating to the same class try. So if I wanted to create an object inside a main function or anywhere else, I have to create like this only. I have to give the class name to which I am going to create an object, and then the object name. Here the class name is, here is only one class try. So the class name is try space, the object name is try to. Now we are going to access the function inside the class. How we are going to access? You see, I am using the object, first object try1 dot get data. Dot is an operator that is used to access the class members by using the appropriate object. Here my class try has two objects, try1 and try2. First I am using the first object try1 to get data, and try, actually there is an error here, try1 dot display, which means I'm using the first object to get data and display it, and I'm using the second object try2 dot get data, and I'm displaying it. So why I'm using this four lines is I want to exhibit one object try1 and another object try2 has two different memory locations, and they can save their own values independent of each other, even though they have a b c. Look at the structure of try1 and try2. What is the structure of try1? The structure of try1 is it has three values. The what is the class? What is the structure of the class? That is the structure of the object. So what is the structure of try1? The structure of try. What is the structure of try? Try has three integers and two functions. So that is the size of the object. So here you can see try2 also the object of, here you see the try2 is also the object of try, the same class try. So try1 and try2 has similar structure, both has a b and c and can access to the same functions get data and display, but they are not same. So this is what we are going to see here. See that by using the first object try1 we are get data and display it, and second function get data and display it, and get ch we are ending it. And now there is another important one. You see here I'm going to define the function. What is the get data is going to do? I'm calling it with, if I call the function, what is the get data is going to do? That is how, that is what the definition of the function. So see how I am defining it, void get data. Then what is this try and what is the symbol? See here, void get data. Where the get data is residing, just go to the top. Where the get data is residing, get data is here. You can see get data is residing under the class try. So if I wanted to display, if I want to define uh, get data, I must write syntax like this. Void is the return type of the function get data space the class in which the get data is residing. In our example the class name is try, so we are writing here as try. But this is what actually this is the class name in which the get data function has been declared, or into which it has been residing. Okay, then what is this? Then what is the symbol? You see, what is the symbol? This symbol is called scope resolution operator. So two colons, which means whatever there is inside a class it is not visible outside the class. This is the first thing we have been already known. So getData is also a function that is residing inside the class try. If I wanted to define it, I must access it, so which is not possible. So I am extending the scope of the variables inside the class. If I wanted to extend a scope of a variable or a function from inside the class to outside the class, I must use the scope resolution operator before the identifier name, before the function name or the variable name. So this is how you must access it. Okay, this void try is the class name into which the getData has been residing, and the scope resolution operator, and there comes getData as the function name, and I am using, there is a cout which is used to display. This is how you must use cout. This is an extraction operator, and enter the value of a. The first line should be printed on the screen is enter the value of a, that is inside the double quotation, that will be displayed straightly onto the screen. Okay, which is followed by endl, means end line. After displaying this, you must stop, you must put an end to it, and by pressing an enter, just this almost like pressing an enter. By if I use endl, the next line is prompted. So after displaying the enter the value of a, the cursor goes to the next line and wait for the value a. If I using my keyboard, if I give 79, it waits for 79 and it fetches as a. Okay, then enter the value of b has been printed and goes to the next line. Okay, and goes to the next line, waited for b. Okay, there comes here ends the getData function ends. Then similarly we are defining the display function, and initially a and b has been added and is stored in C, and the value of C is C, which has been displayed, so it is put under the double quotation and cout. And this line is very important line, the control getting transferred to main. This is the line you must have uh, you must have traced where the control has been coming and going. After calling one particular function, the control has been traveled back to main. So this is what you must have understand this. That is why we are including this line. Okay, let's see by compiling what will happen. By compiling, there is no error, and we are going to run it, and we are running it. There's no error. See, enter the value of a and end l, so it comes to the next line and waiting for the value. I am giving 4. So you must know the first the function is first called by try1, first object. This value of a equal to 4 is the first value, the first object's value, and I am giving enter the value of b, and I am giving 5. So the value of c is 9. Okay, the value of c is 9. So, and the control is getting transferred to main, it is getting transferred to main, and the next line is try2 dot get data. So this value of a is to, this value of a is to what, for try2, for the second object. So let's give 99 and 1. Okay, the value of c must be 100, but it is 9. So there is an error in it. What is an error? Just get back to it and say it. What is an error? Why it is not getting displayed? Because here you must display try2.c. Okay, so try2.display. Now I am compiling it and I am running it on a quick fashion. You see the same number I am giving, 4 and 5. So the value of c is 9. So the try1's c value is 9, and I'm giving 99, and I'm giving 1. The value of c is 100. So the value of c is 9 for try1, and the value of the same attribute c is 100 for try2. This is what I just wanted to convey you. Every individual object has different memory location. Even though we have only declared A, B, and C once, but they have several instances, they have several copies to every object. So every object has its own memory location, has its own A, own B, and own C. So this independent of each other, okay, which is not possible in C. So